Good morning, everyone. Myself, Dr. Veera Pratap, Associate Professor, Department of ECE, ATME College of Engineering, Mysore. Today, I am going to explain about experiment number 6 of Digital Communication Lab, which is simulation of binary baseband signal and bit error rate in AWGN channel using matched filter receiver, both in theoretical as well as using MATLAB. So what is basically a binary baseband signal? What is binary communication? Binary communication, as you all know, it uses only zeros and ones. What is baseband communication? It is a direct communication between transmitter and receiver without any carrier signal. So what kind of mapping we are going to use? So either we can use unipolar non-return to zero, where one is mapped to plus k and 0 to 0, or you can use polar NRZ where 1 is mapped to plus k and 0 is mapped to minus k. Here polar signal gives better performance. So what is bit error rate? So bit error rate is number of wrong bits divided by total number of transmitted bits. For example, if you transmit 1000 bits and the 12 wrong bits are sent means, so bit error rate will be 0.012. So as a conclusion, we can say lower bit error rate means system is more reliable. So what is AWGN channel? AWGN stands for additive white Gaussian noise. What is additive? We are going to add a noise for the transmitting signal. What is white noise? It is having an equal power at all the given frequencies. What is Gaussian? It follows normal distribution. So what will be the received signal? So the received signal is R of t, which is equal to S of t plus N of t. S of t is your transmitted signal, whereas N of t is the added Gaussian noise. So what is matched filter receiver? Matched filter receiver is going to do whether the received bit is 0 or 1. So noise spreads energy everywhere, so we need to use a optimal matched filter. So the matched filter is an optimal linear filter which maximizes SNR and minimizes the DER. Okay, so how it is going to decide? If the output is greater than 0, it decides bit 1 to transmit. If output is less than 0, it is going to decide the bit 0 to bit transmit. So based on the threshold, it is going to decide. For unipolar, that is for 0 and plus a, the threshold is a by 2, and for polar plus minus a, the threshold is going to be 0. So what will be the simulation result we can expect? We are going to expect a graph of BR versus SNR curve. Okay, as SNR increases, BR is going to be decreased. So we need to match the curve for both theoretical and practical values. So what was the summary? So binary baseband, it is a simple pulses of the bits zeros and ones. AWGN channel is going to add a noise. Okay, matched filter, what it will do, it will maximizes the SNR. What is the decision rule? It recovers the transmitted bits. Okay, so finally BR versus SNR shows the performance of the system. So in the MATLAB code, we are going to explain what's the step one. Step one is we are going to set the simulation parameters. Okay, step number two, we are going to generate the data pulse shape. Okay, randomly we are going to generate a bits of zeros and ones. Step number three, we are going to initialize the bit error rate vector. Finally initially we are making all the values to be 0, and we have taken the 5 SNR values from 0 to 20 in a uh, this one of 5 5. Okay, 0 5 10 15 and 20. Next we are going to assign a loop for each SNR value. So we have totally 5 SNR value, so it is this loop is going to perform iteration for all the 5 SNR values. Okay, next in fourth this thing, AWGN channel is going to add a noise. Okay, next, matched filter reception. What it is going to do? It is going to identify, it is going to generate the identical, it is going, So the next step is it is going to calculate the bit error rate. Next, finally, it is going to plot the result in a semi-log graph sheet where x-axis and y-axis will be SNR and bit error rate. Okay, so we are going to next open online MATLAB. I've already pasted the program. Okay, so just go and run this. So as a result, we are going to expect a graph of BR versus SNR. It takes some few seconds. You can observe a nice graph of bit error rate versus SNR for unipolar NR set. Okay, hope you have got the concept. Thank you.